Hey, what is up everyone? Welcome to Ritz Learn. And in today's video, we're going to learn about vectors addition and subtraction and what are the laws that can be applied to them. So before I go ahead, I would like to show you a few examples with the help of which it will be easier for you to understand the concepts. Now, as you can see over here, that there is a block placed on a ground and you've been trying to apply force from one side in order to push the block. So let's say you've been applying the force of say 10 newtons. Now let's assume that the block that you're trying to move is very light, and that's the reason if you try to move it forward, the force that you've been applying on it is of 10 newtons and it is in the same direction. Now assume that there is someone who is trying to stop you to move that block. So he's been applying, suppose say 5 newtons of force from the opposite direction. As you can observe that the force that you have been applying, that is of 10 newton, it's greater than the force applied by other person, which is 5 newtons. So the block will still gonna move in the same direction. However, the effective force applied on the block will be reduced. For example, 10 minus 5 newton is equal to 5 newton. So it was a very simple example, and the way we said that it's in the layman term. Let's talk about the same scenario in the vector notation. So let me create few vectors. So this is a vector of the force that you've been applying, that is of 10 newtons. Let's name it as a P vectors, and the person who is trying to stop you, his vector will be of 5 newton, and let's name it Q vector. Now these two vectors are parallel to each other, which means they both are aligned in the same line. So as you can see over here that they are parallel to each other and they are in the same line. So in such cases, when two vectors are acting along the same line in same or opposite direction. So over here, as you can see, in the same line that there are two forces that is opposite in the direction, then you can add or subtract those vectors. So as you can see over here that there are two vectors, so we're gonna subtract it, and the new vector that will be created will be in the same direction, and such vectors are known as resultant vectors. I had explained you this in my previous video. So resultant vectors are the result of two or more vectors. Let's name this resultant vector as R vector. Therefore we can say that R vectors is equal to P vector minus Q vector, minus because they are in the opposite direction, and since P is greater, P would be the first, and we're going to subtract Q from the P, and that's what we call a vector notation. So how about magnitude? We'll give a separate notation about magnitude. Therefore R's magnitude equals P magnitude minus Q magnitude. Therefore 10 newton minus 5 newton is equals to 5 newton. Let me tell you one more thing with regards to vector addition and subtraction. You can add and subtract only those vectors whose units are same, means they should be the same kind of vector. So as you can see in these example, these both kind of vectors are force, and that's the reason you can easily add and subtract them to get the resultant vector. But let's suppose that you have a force vector and a velocity vector. You cannot add or subtract them because they are totally different kind of vectors. Plus they have different units. For example, it could be in meter per second, another one would be in the newton, so you cannot add or subtract these two kinds of vectors. Please remember that. Now let's see another example. So now in this example, we cannot remove that person who was trying to apply the force from the opposite direction. Now let's call your friend who is trying to help you to push this block and he's been applying the force in the same direction of 7 Newton. Means you and your friend are trying to push this block in the same direction. Now, since you both have been applying the force in the same direction, so if you understood the last example, since it was in the opposite direction, now this time the resultant vector that you will get is by adding these two vectors. So P vector is your force and Q vector is your friend's force. So the R magnitude would be P's magnitude plus Q's magnitude, that is 10 plus 7 equals 17 Newton. So let's see another example now. So this is a third example now. Now, as you can see over here, this is the same block, but the viewing angle is different. Now we are viewing this block from the top view. So as you can see that this is a block and this is the ground plane. So now you were applying force over here, that is of 10 newtons. And in our earlier example, that there was a person who was trying to apply the force from the opposite direction, left direction, that is of the same force of 5 Newton. So now you cannot add this to get the resultant vector, because in the last example they were in the same plane, they were parallel to each other, and that's the reason we were able to add them to get the resultant vector. But now over here they're not parallel to each other. The second vector is in an angle. So now as you can see that these angle is a perpendicular, but it could be any angle. The second force can be applied from this angle or that angle. So since these vectors are not parallel to each other, we're gonna apply a vector law to get the resultant vector. The first vector law that I would like to show you would be triangle law. It's very simple. The triangle law says that, let's suppose we create a new vector, and let's call it P vector. Now create another vector and place it in such a way that the second vector's tail should coincide first vector's head. Means second vector's tail should touch the first vector's head. So let's name the second vector as a Q vector. So P vector is equals, again, would be 10 Newton and Q vector would be 5 Newton. Let me write it down over here. So triangle law says that your first vector's head should coincide the second vector's tail. So now you can assume, or you can see, that if you create a line over here, then it would be a triangle. So the third line that we have now created, that would be the resultant vector, and the head of the second vector would be the head of the resultant vector, and first vector's tail would be resultant vector's tail. So we can write over here that R vectors equals P vector plus Q vector, and resultant vector's magnitude, for now I'm not gonna solve it. So now you're gonna say that let's take the first vector as Q. Now you're gonna create a P vector in such a way that its head, P's tail, is now Q's head. Now again you're gonna create a line which will touch Q's tail and P's head. Again you get a triangle. So as you can see over here, the resultant vector is still on the same line. It's still on the same direction, though you have changed the sequence of the vectors. Earlier you had taken P vector first, now you have taken Q vector first. The resultant vector is in the same direction. So it doesn't matter if you write P plus Q or Q plus P to get the resultant vector. Still your answer gonna be the same, and this is known as commutative law. So before I go towards next law, let's see a few more examples of the triangle law. So now I'm going to create these two vectors. The first one would be the C vector, and another one would be the D vector. Now you have to add these two vectors to get a resultant vector. Now how are we going to use the triangle law over here? Let's take C as a first vector. Now we're going to create a D in such a way that the D's tail should touch the C's head. So let's draw in the same way over. I'm going to create a D over here. Now as per the triangle law, let's create a line over here. Now so we have got the head and tails of our resultant vector. So this is our resultant vector. So you can name anything, you can name these vectors anything. I'm just giving it a name like C, D, or you can name them anything. It's just a naming convention. Let's create a straight line. Let's call it a X vector. Another one would be Y vector. You can name them anything. Now let's solve it with the help of triangle law. So whatever vector that you want to choose first, you can go ahead with that. There is no hard and fast rule. Let me take X first. So now I'm going to create Y over here. Let's create a triangle by creating one more line. All these things make sense to you now. Now let me explain you how to calculate magnitude. But wait, before finding out the magnitude, let's see another example. That would be the polygon law. So polygon law is just an advanced version of the triangle law. So polygon law, we're gonna use the polygon law when we have more than two vectors. So since in the earlier example there were only two vectors, it was easier to find the resultant vector. So now let's assume that there is another person in my previous example. Now he's pushing from some different angles. Now let's see how we're gonna solve it. You can use a triangle law as well. So how can you do that with the triangle law? That you will first calculate the so you will first find the resultant vector with the help of these two vectors. Now again, so once you get the first resultant vector, you're gonna use that vector with the new vector to get the another resultant vector. So that would be your final result. Polygon law is also similar to that, but it's just a one step. You don't have to do it all over again. You can get the result in one shot. Let me show you, then it will make more sense because you have to do this multiple times. So this is our first vector, 10 newtons. Let's create another vector. There will be 5 newtons. Now we're going to create the third vector. Now let me make it bigger. Here we go. This is another vector of 5 newtons. So let's create another. So let's create one line over here, and you can name it anything. Let's PQ. So we're gonna find first two. Let me clear P and Q vectors for a moment. But they are still there, but just for the understanding purpose, I'm going to clear them off for a moment. Now let's create this. Let's join these two, so there will be a new triangle. So basically, this is P vector plus Q vector plus A vector. So this is your polygon law. So polygon law has another law. So we had solved P vector plus Q vector plus we had added another vector. You can also inverse this sequence. So you can either add Q vector plus A vector plus you could have been added P vector. So the results of both these two would have been same, and thus we call it associative law. Hope this makes sense. Now let's look at the third law. The third law is parallelogram law. As the name suggests, the last time as we had created a triangle with the triangle laws, so this time we need to create the parallelogram. Let's see what is parallelogram. So the parallelogram are those kind of quadrilaterals whose opposite sides are parallel to each other. So this is one of the example of parallelogram. So as you can see over here, these two opposite sides are parallel to each other. So that's what we call it, kind of parallelogram. So we can do the similar type of example, but however I would like to give you another example. Assume there is a p vector, and let's draw q vector over here. So I have got two vectors. So remember in the triangle law, we had combined one's tail with another's head. So however, it's a bit different in parallelogram. So in parallelogram law, you have to place these two vectors in such a way that tails of these vectors should be on same point. Let me demonstrate that for you. So now you have to draw that same vector over here. Now as you can see, the tails of both these vectors are on the same point. So now we have to create a line which is parallel to the q vector. So I'm now going to create a dotted line over here. Similarly, we need to create a line parallel to the p vector, and you have to draw in such a way that it should join the head of the point q. So as you can see over here that we have got one parallelogram. So according to the parallelogram law, the diagonal line of this parallelogram is gonna be the resultant vector, and its tail would be the same as these two vectors, that is p and q. I'm going to show you a few more examples of parallelogram. So let me create a vector of 10 newtons, and I'm going to create a 5 newtons vector in such a way that both of their tails should touch each other. So now you have to create a line parallel to the 5 newtons vector. I've created this one. Again, you have to create another line which is parallel to 10 newtons vector. It should be touching the 5 newtons vector. So whatever diagonal side of this parallelogram is our resultant vector. And let's call it r vector. And we can write it down as r vector equals to p vector plus q vector. So far we have learned that with the help of these vector, with the help of these laws, we can find the resultant vector. However, we have not seen how to find the magnitude yet. So let's see how we're gonna calculate the magnitude of the resultant vectors. So let's take the same example again. Let's create a vector of 5 newton, another vector for 10 newton, and this would be a resultant vector. Let me call it a r. Let's name it r vector. So as I had advised you in my previous videos that the length of the vector represents magnitude. So if we want to find the magnitude of r, so all I need to do is to just get the magnitude of these two vectors. Now the question is how I'm gonna find the magnitude of these vectors. As you can see, this triangle over here, it's a right angle triangle, which means that the vectors are perpendicular to each other and their angle is 90 degrees. So we can easily get the magnitude of the resultant vector by applying hypotenuse theorem. So since this is a right angle triangle, therefore our R vector can be calculated with the help of hypotenuse theorem. So the resultant vector would be the square root of 10 square plus 5 square. But let's assume that it's not 90 degree and it's some other theta. For example, it could be greater than 90 or less than 90. So how are you going to calculate the resultant vector's magnitude? For this, so there is a formula with the help of which no matter what theta you have, you can easily get the magnitude of the resultant vector. Let's see how we can do that. So let's start derivation. We're gonna solve this with the help of geometry. So we're gonna create two vectors over here. So this is my first vector over here. So let me create another vector over here. And as you can see, the tails of both these vectors are lying on the same point, and the angle between them is theta. There could be any angles. Let's assume it's theta. So in the parallelogram, we used to create a parallel lines. I could have drawn the parallel line over here, which is parallel to the, in the same way I would create another parallel line. So whatever would be our diagonal side, it would be our resultant. However, in this problem, we want to find out the magnitude of the resultant. Let's see how we can solve it. So in our previous example, it was comparatively very easy to get the magnitude of the resultant vector because it was a right angle triangle. We're gonna do the similar thing in this scenario as well. It's not a right angle triangle because it's in some theta angle. Let's try to make it a right angle triangle. Let me mark some points over here. So let's name the bottom vector over here as OA, and over here it's OB, and the last one would be OR. Now let's extend this OA. So now I'm gonna touch the head of the R with OA in such a way that we get the right angle triangle. So as you can see over here, we have got a 90-degree angle. So if you look at the triangle OMR carefully, you will find that this is a right angle triangle. So this OMR. So since OR is our hypotenuse, therefore OR square equals MR square plus OM square. I may able to get the OR. However, I don't know anything about MR or OM magnitude. Now let's find them. So if you look at the OM carefully, it is OA plus AM. Let me write it down over here. So MR square plus OA plus AM, the whole square. So I know that OA is the magnitude of a vector. So I have the OA. However, I don't have any idea about AM. Let's find it. So since we know that this is a parallelogram and OB is opposite to AR, and they're not just only parallel, they're also equal. So if I talk in the terms of magnitude, then we can say that AR's magnitude equals OB's magnitude. So they both have same magnitude. And the angle over here, which is RAM, it's a theta angle because as you can see, it's parallel to angle O. So we would call them corresponding angles. Now I want you to have a look on another triangle that is RMA. So in triangle RMA, so we're gonna find out sine theta of RMA. So basically sine theta equals to opposite upon hypotenuse MR upon AR, since it's our hypotenuse. Since AR equals OB, let me change it to OB. Therefore we have got mr equals ob sine theta. So we have got one value or one magnitude, that is mr. The similar way we can find cos theta, that would be am upon ob. In the same way, therefore our am equals ob cos theta. So now we have got mr plus am. So since we have got mr and am, we can substitute them over here in our first equation. Let me continue over here. So OR square equals, let me write it over here. So OR square over here. So OR square equals OB sine theta whole square plus OA plus OB cos theta the whole square. Let me solve the brackets. So we got OB square sine square theta OA square plus 2OA OB cos theta plus OB square cos square theta. So as you can see over here, we have got OB sine square theta and OB square cos square theta. We can extract the common from both of them. So let me write it down. OA square plus OB square sine square theta plus cos square theta. Then we have the remaining ones, that is 2 OA OB, given this over here. So we can see that we have got sine square theta plus cos square theta. So we have got the trigonometric result for this one, which is equals 1. So we got this as 1. So what we have left with us is OR square equals OA square plus OB square plus 2 OA OB cos theta. So we got OR equals square root of OA square plus OB square plus 2OA OB cos theta. Let me write this result in a simpler term. Assume that we had just a vector in instead of OA, or R instead of OR. So I can say that R vector's magnitude equals square root of a square plus b square plus 2a b cos theta b into cos theta. So a and b is a magnitude of a and b, plus, and cos theta is an angle between a vector and b vector. So since we have got this formula, so with the help of this angle, if we know the magnitude of these two vectors, we can easily find out the magnitude of the resulting point. This formula. Assume that our cos is 90. That's just similar to our previous example when we had a 90 right angle triangle. So in that previous example, if you remember, we had 5 and 10 newtons and 90-degree angles. So we had theta equals 90 degrees. So cos 90 would be 0. So this whole term would be 0. So what we have left with us, that is r equals square root of a square plus b square. So as you can see, it's a simple hypotenuse similar to that. So let's take another example when we have theta equals 0, which means that there is no angle between the two vectors. So basically that means the vector A is lying over vector B, so that they are actually in the same line and they are parallel to each other. So let's write it down as equal to that resultant equals a square plus b square plus 2ab. Here we can write r equals a plus b the whole square root of a plus b the whole square. As we had learned in our very first, I think second video, that if the vectors are lying on the same line, we can easily add or subtract them. Since there is no angle, theta is 0. With the help of this formula, we get the magnitude directly. Let me write it over here. resultant vectors equals square root of a square plus b square plus 2ab cos theta this is actually our main formula. Now since the video is very long now, I would like to stop over here. So quick recap, today we learned triangle law, polygon law, parallelogram law, and we learned how to find the magnitude of the resultant vectors. I wanted to cover resolution in this particular video, but since the video is too long, so for now that's it. So if you like the video, please don't forget to like, share and subscribe to my channel. Thanks for watching.